Origin of soil and composition of layers. Soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. The Earth's body of soil is a phytosphere, which has four important functions. It is a medium plant growth. It is a means of water storage, supply, and purification. It is a modifier of Earth's atmosphere. It is an habitat for organisms, all of which, in turn, modify the soil. There are six composition of layers. The first one is humus, the top organic layer of soil, made up mostly of leather and humus. The topsoil. The layer called topsoil, seeds germinate and plants roots grow into this dark colored layer. It is made of humus mixed with mineral particles. Elevation layer. This layer is light in color. It is made up mostly of sand and slate, having lost all of its mineral and clay as water drips through the soil. Subsoil. It contains clay and mineral deposits that it receives from layers above it when mineralized water drips from the soil above. Regolith. It consists slightly broken up bedrock. Plant roots do not penetrate this layer. Very little organic material is found in this layer. And the last one, bedrock. The bedrock layer that is beneath all the layers.
Hello, I'm going to talk about erosion. So first we have to know what is soil erosion. It's a natural process. It's when topsoil, which is the uppermost layer of the ground, is moved from one spot to another. So this has been occurring naturally since the first land plants formed the first soil. Accelerated erosion by water is often associated with early agriculture. Water erosion's association with unwise agricultural practice was first noted during the early decades of the 20th century. During this period, the period of colonialism, the imposed adoption of European agricultural methods frequently led to accelerated erosion in developing countries. So that's why the problem often continues to the present day. Now I'm going to talk about the consequences of erosion. So all soils can suffer erosion, but some are more vulnerable than others. Soils with dispersible subsoils, for example, are subject to serious erosion by tunneling and gully formation. Soil erosion removes valuable topsoil, which is the most productive part of the soil profile for agricultural purposes. So as examples of the consequences of erosion.
Desertification. Desertification is a type of land degradation in which a relatively dry area of land becomes increasingly arid, losing bodies of water as well as vegetation and wildlife. A variety of factors causes it, such as climate change and overexploitation of soil through human activity. The consequences are farming becomes next to impossible, hunger, flooding, poor water quality, overpopulation, and poverty. The solutions are policy changes related to how people can farm, policy changes to other types of land use, education, technology, and sustainable practices to prevent desertification from happening.
I'm going to talk about acidification. Acidification is when the ocean absorbs about 30% of the carbon dioxide that is released in the atmosphere, and as levels of atmospheric carbon dioxide increase, the levels in the ocean also increase. When carbon dioxide is absorbed by seawater, a series of chemical reactions occur resulting in the increasing of concentration of hydrogen ions. This increase causes the seawater to become more acid and causes carbonate ions to be relatively less abundant. Carbonate ions are an important building block for structures such as seashells and coral skeletons. Decreases in carbonate ions can make building and maintaining these shells and other calcium carbonate structures difficult for calcifying organisms such as oysters, clams, shallow water corals, deep sea corals, and calcareous plankton. This change in the ocean chemistry can affect the behavior of non-calcifying organisms as well. Certain fish ability to detect predators is decreased in more acidic waters. When these organisms are in risk, the entire food web may also be at risk. Ocean acidification is affecting the entire world's oceans, including coastal estuaries and waterways. Many economies are dependent of fish and jellyfish, and people worldwide really rely on food from the ocean as their primary source of protein. We can stop ocean acidification by cutting carbon pollution drastically and immediately. We are exerting a massive influence in the oceans with unpredictable and potentially catastrophic consequences if we continue to pollute.